Guys, attendance enabled. Did you guys face any kind of lags in the previous lectures? Because it looks like I'm continuously getting these beep sounds in some kind of broken mode. So, I mean, it's WebEx, we all know, but yeah. Anyhow,
This is our first class of the day, I guess.
oh, okay, fine. So we'll figure it out what happens. So yeah, let's see. Let us see how many people are there. Okay, it's 42. Let us wait for a couple more minutes. Okay, so I think we've reached the 50 mark. Usually that is what I expect. Okay, so yeah, sorry for not being able to upload the lecture. I mean, it is getting delayed because of things at my personal end. Um, but I'm trying my best to upload the last two lectures as quickly as possible. They are basically C++ related lectures, and they are more about introduction of classes and access specifiers and stuff like that, and basics of inheritance, right? So how do you create a class, extending another class in C++? So these are the two lectures that are remaining. I'm trying my best, given all the personal problems I have, to complete them as quickly as possible and give it to you. Um, but today, what we'll do is at least the theoretical part of inheritance that I have already uploaded the lecture for. So it's slightly long, and it might be boring as well because uh, it's theory, right? I mean, so it becomes really difficult to keep yourself interested and motivated when you are not really writing code. So so please, like, try to try to be focused when you'll actually write code related to these concepts in C++. Maybe they'll be much more interesting, but we just need to learn some theory before we can go and write code. So today is mostly about the concepts. It might be boring, but please try to stay awake. That is the idea. Okay. Let me start. By the way, this lecture is already there on YouTube. So uh, if you have already watched it, then you can probably start with some questions as well. Um, Otherwise, we'll just go through the lecture like we did for the other lecture. So I guess no questions. Maybe not many people have watched it. Uh, Anyhow, so let's start. And again, as soon as I go in the full screen mode, uh, I will not be able to check the chats. So I hope that WebEx helps us out and doesn't cut me off erratically, because otherwise I won't even know that I'm audible because I can't see the chats. So anyhow, let's start, guys. So the idea of inheritance as such, right? What exactly is this whole idea? I think you would must have heard the term inheritance. Okay, at least one inheritance that in one context in which inheritance is quite often used is something that you inherit from your parents or grandparents, right? In all those Hindi movies you see. Um, Maybe in other movies as well, that that people fight over the inheritance, right? I mean, what exactly are you going to inherit from your forefathers? Okay, so basically whatever you inherit is something that was a property of your ancestors, and now you are just going to take it up as it is, right? In some ways, inheritance is a very common concept that is not just there in Bollywood. It's there in the real world. You'll find it at many places in the real world. So let us try to take one example. Can you cook a pizza at home? I did not know whether we can or not, but during the lockdown period, I figured it out that it is possible to do that. So apparently, what you really need is that they sell these pizza bases in the market, right? They look like flat, fluffy, uncooked chapatis or whatever you call them, right? And so you can buy them, these pizza bases, and then there are some other ingredients, basic ingredients that you'll need. So they also sell something known as a pizza sauce. Okay, so what you are supposed to do is you have to supposed to apply that pizza sauce on the base, and a common ingredient, probably the most common ingredient for pizza, is cheese. So you grate some cheese over this sauce and the overall pizza base, and then you put whatever toppings you would like, right? There are different types of toppings. Different people might like different types of toppings. So for example, some people might like onions and tomato, some others might like paneer and capsicum. So there are basically so many options. So what you can see here is that if you start inspecting this whole pizza cooking process, there are some steps which are common, right? I mean, irrespective of what pizza you are going to make, you still need a pizza base, and you'll need a let probably you'll need the pizza sauce, some cheese, stuff like that, right? So at least this much part is kind of common, right? And beyond that, there can be like n number of different ways in which you can make the pizza, right? It depends on what exact toppings are you interested in. So if we try to somehow make this whole process a little more, let us say, systematic, we can see it something like this, right? So there is a pizza base, there is pizza sauce which is applied over the pizza base, then we grate some cheese over the pizza sauce, and then here there is things change. Okay, you can have n number of pizzas here, and the only things that will probably change are at this particular level. So overall, this process, in this whole process, you can see that there are certain common elements, and at one point in the whole process, if you want to prepare one product, the process changes as compared to, let us say, another product. So this whole idea, the whole idea where we are trying to build stuff in some kind of a hierarchy, right? So you start with the common parts of the process, and then at some point of time you bifurcate or trifurcate, or basically you take it in different directions, right? So this whole idea of trying to build systems, so you can do these things with computer science related entities as well, right? So what we can do is, if I want to create, let us say, an entity, a class, we can start with a generic class, a class that has attributes which are applicable for many real world classes. So I can start with a class which has these common attributes, and then I can start, I can inherit this class, I can inherit whatever it has, and from that point onwards, I can have multiple classes which are in some ways a descendant of this class, right? This generic class. Okay, so this in this whole process, what really happen is, at different layers, at different steps, we keep on adding more attributes to the entity, and there can be multiple entities which are, let us say, having a parent child relationship. Okay, so there is one parent and there are like multiple children. By the way, it's not really necessary that you have just one parent. um, uh, in real world, it is quite possible that you have two entities being the parent of one entity. But for now, just to keep the things simple, let us just try to understand that there is a kind of hierarchy here, where one particular class has just one parent, like this. So if I extend those metaphor, I can say that pizza is a type of wheat based dish. Another type of wheat based dish are noodles, and then instant noodles, the one, the Maggie and Sunfeast kinds. They are basically just another type of noodles, right? And there are other types of noodles as well. Similarly, pizza, okay, there can be, it could be onion and tomato pizza, or paneer and capsicum pizza, or some other pizza. Basically, this is a kind of a hierarchy, right? Every node in this whole hierarchy, in this whole tree, it inherits some properties from its parents. Okay, let for now, just let's say it inherits all the properties. Okay, let's not make it some. Assume that it inherits all the properties of its parent, and then it adds some customizations, something specific. Okay, so this whole phenomenon is known as inheritance, right? So you are going to create classes, but instead of creating these classes in like one go, where there is a class which has, let us say, 10 different attributes, instead of doing that, what you're going to do is, you're going to create it hierarchically. So you create one class that has probably 5 attributes, then you create another class, inherit the first class, you add 3 more to it, and then you create another class, inherit the previous one, and you add 2 more attributes. So 5 plus 3 plus 2. So instead of creating one class with 10 attributes, you create a class hierarchy. So this whole phenomenon is known as inheritance, and in this whole process, the class which is higher in the hierarchy is known as a base class, and those which inherit this class are known as derived classes. Okay. And we can view the derived classes as specializations of the base classes, right? So basically at each level, I'm going to make it something more specific. So if I take the example of, let's say, automobiles, I can say there is a class called automobile, and then there can be 2 types of automobile, let us say. um, the diesel automobile and the petrol one. Maybe there's another type, CNG, LPG. So all these are, let us say, another level, right? These are all automobile, but they have some more properties. The diesel automobile will not run on CNG. The petrol automobile will not run on LPG, something like this. And then you can extend petrol automobile to, let us say, some specific car or some specific vehicle, things like this, right? So essentially, at each level, you can say that a car is a type of petrol vehicle, a petrol vehicle is a type of automobile, whatever it is, right? So at each level, the derived classes are essentially the specializations of their base classes. Now, when you create a class in such a way, right? So as I said, one way to do that was you add 10 attributes to one class and you are done. But now I'm saying that, okay, let us do it hierarchically. Let us create one class, allow it to be inherited by another class, then create yet another class, and then, inherit the second class, so on and so forth. So a question that arises is, whenever I create any one of these classes, should everything within this class be visible to the outside world, or should I try to, constrain certain things? It is possible that maybe in class there are certain things which I really do not want to expose to the world. So an example could be, when you buy these pizza bases, they are pretty generic, right? Generic as in you can cook any pizza with the help of these pizza bases. It could be paneer and tomato, or whatever it is, mushrooms and stuff like that. But the idea is, you do not see the recipe of these pizza bases written along with the packing, right? I mean, at best probably they'll just write the contents uh, of the pizza base, but they won't write the recipe, right? Because according to them, how exactly was the pizza base built, it doesn't concern you, right? You are only supposed to buy the pizza base and use it. You are not supposed to know the details of how the pizza base was created, right? So this is an aspect of object oriented programming, that whenever you are creating classes, especially from the perspective of inheritance, there might be certain questions that you have to ask yourself. Is this property, is this field, is this method in this particular class necessary to be made visible to the rest of the world, including the derived classes, or should I make it a private property of this class, right? So these decisions, what exactly is hidden and what exactly is public, actually impact the amount of inheritance that you can do. Why? Because if the class is too restrictive, let us say, the only thing that are visible or that are available for the derived classes are, let us say, 2 out of the 10 fields that the class has, right? So now it is probably too restrictive. The person who's going to extend your class will have to add far too much to his or her code, as compared to what he or she would have liked. So if the class is too restrictive, it has very few visible or extendable traits, it may not actually be useful at all, right? Especially from the perspective of inheritance. On the other hand, if you make it too permissive, okay, there is a risk of too much exposure or change of behavior. So an example that I gave in the lecture is, let us say the pizza bases that these guys are making, if they are so good, right, they are so customizable that you can use a pizza base to create noodles, for example, then it's the basic behavior, it's called a pizza base. It's supposed to be used for making a pizza. If you can customize it to that level, that it can be used to create noodles, then probably it is wrong, right? So there has to be, you should give customizability, but not too much customizability. That is the idea. So there is a principle related to this. It's known as the open close principle. This is actually a very old principle that still lurks around. So what does this principle say? It says the software entities, for example, classes, modules, functions, etc., should be open for extension but closed for modification. So there are two terms here, right? Modification and extension. So what exactly is the overall idea of what is modification and what is extension? So assume that, right, it is possible to turn the pizza into noodles, pizza base into noodles. This is basically an example of modification. The core behavior of my entity can be, completely changed. Whereas whereas applying the sauce and cheese and toppings on top of the pizza base is probably an example of extension, right? So the pizza base still remains pizza base. Its properties in some ways are preserved, and you use it to build something more complex. Okay, so in essence, the whole idea, right, the whole crux of the matter when it comes to inheritance is that you whenever you extend an entity, its core behavior still remains there. Okay, its core behavior should not be altered. You basically add more customizations over it, so that this is why I can say that x is a specialized version of y, where x is a derived class and y is a base class. So yeah, any queries still here? Yeah, it's really boring, but we have to go through some of these concepts so that when you start writing code, at least you understand, what exactly does it mean by inheritance, what does it mean by overriding and stuff like that. So this is, I do understand that this is theory, and maybe if we had regular classes, I would have mixed up these lectures in a different fashion. I would have basically made theory then some code and theory then some code kind of thing. But because now we are running behind schedule, I had no other option but to do it like this. So anyhow, any questions till now? Okay, let me check the chats as well.
Sir, is it necessary that
Yeah.
all the properties of the uh, like the higher class
Mhm.
is common with the like so lower class or whatever?
Yeah, so essentially, uh, this is a decision that you will have to take. The short answer to this is yes. The long answer is that all the properties of the base class, the class that is higher in the hierarchy, will be shared with the derived class, but it may not be accessible to the derived class. Okay, so when I say accessible, it is something like this, right? I'll give you a pizza base to cook your pizza, right? And you can use the pizza base pretty much, and in any form that you want, right? You can flip it over, you can punch it, you can do whatever you want, right? It is still, as long as it is a pizza base, it is a pizza base. You can use it to cook something over it, right? You can apply sauce and stuff like that. But I will not tell you how the pizza was made, right? I won't tell you how much dough I used. I won't tell you whether I used any yeast or not. Okay, all those things I may not tell you. So it doesn't change the fact that it is a pizza base. Even if I did tell you the recipe, it will still be the same pizza base. But in some cases, I may not tell you the recipe. I'll just give you the pizza base and I'll ask you to use it. So that is the idea with inheritance as well. The overall behavior of the base class will be exactly as it is supposed to in most cases. And in fact, that is what I said, that you should not allow change in behavior. Okay, you should try to restrict your classes in such a way that the core behavior cannot be changed, but at the same time you are allowing certain extensions. There are certain ways in which your classes, your entities can be extended. I know it's a bit difficult, so let us say, I know when we'll see that this inheritance example later, maybe it will be a little more clearer. But the idea is,
So,
yes. Yeah. Okay,
so
go ahead.
basically, it's like we can use the functionality, but we don't know how that functionality is achieved.
Yes, that is the overall idea of open close principle, that you can use the functionality to build something higher, but you should not know the details. This is the core in some ways of the open close principle. Another example could be, let us say, you whenever we buy a car, the car is very well polished from outside, right? I mean, there all the machinery is within the bonnet. For example, if you want to see how the engine works and everything, you have to open up the bonnet and then you can see. But for 99% of people, they don't really care about the machinery as long as it is working, right? I mean, you don't even open the bonnet, for example. If the car is working, it's fine. I don't need to know where is the engine, where are the other parts, where is the battery, so on and so forth. So that is the same thing, that um, of course, in a car you can open up the bonnet. The idea is, let us say, if you had a car whose bonnet was sealed, right? You cannot open it. You can just drive the car, but you can't open the bonnet. Then in some ways, that is exactly the same, that my class, my entity is open for use, for extension, but I'm also at the same time trying to hide the details. Okay, so just imagine, if the bonnet is open, I can go and do something with the engine, for example, right? I can open up the engine, I can mess it up. Okay, so the engine is still available for modification, and that should not be the case. That is the idea.
Okay, sir.
Yeah, any more queries? I know these are all theoretical things, and it might be a bit difficult to correlate them to computer science. But this is one of the beauty as well of this course, that now this is a course which helps you in graduating from a coder to an engineer. Okay, this is something that you have to understand, that when you're hired by a company to work, coding is of course a basic skill, but they hire an engineer. Okay, an engineer is far more than just a coder. Okay, so an engineer is supposed to understand a problem and find out a crisp solution for it. Building the solution is the second part, but you have to first plan how the solution will look like. So whatever we are studying right now, this is in some way the part of planning the solution. How do you plan the solution well? And then of course you have to execute it. Okay, anyhow, any queries? Any more queries?
Sir, how could we figure out that which should be private and which should be
Yes.
public?
Yes, so this is a rule of thumb. Let me actually, in fact, I'll go through these slides later. But just to give a heads up, a rule of thumb, okay, is that usually all the fields of a class, we keep them as private unless we have a very good reason for not having them as private. Okay, and we keep all the methods, all the functions of the class as public, unless we have a very good reason of not having a function as public. So maybe for a beginner, the rule of thumb is just make all the fields as private and make all the methods as public. And then as you grow as an engineer, right? In fact, not just as an engineer, when you start coding, you'll realize, oh, maybe I need this field to be non-private. Okay, so you just make that particular field as non-private, or you can say that, okay, I probably don't need this method to be public, so you make that as private, something like this, right? So in the beginning, the rule of thumb is fields private, methods public. Um, but there will be exceptions, as you will come to know. Okay, any more questions? Okay, so let's move forward. So let us have a look at an example now, okay, an inheritance example. So I don't know how many of you actually play or follow cricket. It is probably the biggest craze in India, maybe after politics. But yeah, but cricket is very common, right? Even if you don't watch it, maybe you still have some kind of basic knowledge of cricket. It's a bat and ball game, and there is a team which bats, then the other team balls and fields, and then the team which was fielding and bowling, it gets a chance to bat, and then there is a concept of run, and whomsoever scores more runs wins, blah blah blah. So this is for those guys who are not really into cricket. So sorry if I have taken an example which is not that well absorbable for you, but still, right? So what happens is, this international cricket that is played, the things like IPL, it was in news a few days back. It is the international. Actually, IPL is not international cricket. Sorry. So, but yeah, international cricket is played in three formats. These formats are known as Test cricket, ODI cricket, and T20 cricket. Out of these, ODI and T20 cricket are also known as limited over cricket, because the number of deliveries that can be faced by the batting team in these two formats there is a limit, right? The maximum number of deliveries that can be faced. And in Test cricket, there is no such restriction. Okay, the number of deliveries that can be faced by the team are unlimited. So we call these two as limited over cricket. So now let us say you're building some system, and this system is supposed to have an entity. Okay, and this entity is for a new um, cricketing format called T10. If I'm not wrong, it is already being played in some forms here and there. But let us say it is an international cricket form now, and you have to represent it in your system through some class, right? So what information should be stored in the fields of these classes, of this class? You'd probably need to store. So at the beginning of each cricket match, there is a toss. Okay, so you'll probably need to know the result of the toss, who won the toss. Then you'll probably need to know the names of the playing 11. There are 11 players in a team of cricket, by the way. So you need two playing 11s which are playing against each other. Then you'll need to store the scorecard for the first innings, and as in the team who batted first. Okay, so there will be a scorecard for them, and then there will be a scorecard for the team which batted second, and then you'll need to store which is the winning team, so on and so forth. So there can be many more pieces of information that you have to store, but these are just some examples. So one way to create this class is something like this, right? So all these fields, you just add them to one class, let us say called T10 cricket match. Okay, and you add all these fields to it. And here, by the way, the team and innings are classes in themselves, right? So basically team A, team B, and scores, which is basically an array, are not really and this winner also. Actually, I think everything is, is an object here. So all these are actually objects. They are instances of other classes. So this is another way in which you can link two classes. One way is inheritance. We are studying about it right now. The other way is known as aggregation. The concept of aggregation is that you don't inherit a particular class, but you basically create an object of that class and add it as a field. So this is all examples of aggregation. We did see some examples of aggregation during the modeling lecture, and we'll look into the aggregation when we create class diagrams. But anyhow, for now, just assume that these are, let us say, structures. Okay, team and innings, they are just structures. So this is a class T10 cricket match, and it has these fields. So this is one way to create this class. Okay, now, another way, and by the way, except for the scorecards for a T10 match will be slightly different, because there will be a maximum of 10 overs. In T20 or ODI, it will be 20 or 50. In test matches, there is really no limit on how many number of overs will be bowled. So, except for the scorecard in these in out of these fields, except for the scorecards, everything else is basically common for all the cricketing formats. Okay, you have a toss in test matches and ODIs and T20s as well. You have only playing 11s, right? I think now they have some rule where you can have a have some kind of a concussion substitute or something like that. But yeah, you'll have to name a playing 11 for all these three types as well, and there will be probably a winning team in in most cases. In test matches it could be a draw as well, it could be a tie as well, by the way. But yeah, in most cases you'll have a winning team. But all these fields are applicable to all the cricket matches, not just T10 cricket matches, right? So another way to create the same functionality is that you first create a class called cricket match and add these fields to this class, and then you inherit cricket match and create another class called T10 cricket match, and you simply add the scorecards here, because you say, okay, this will be different from for different types of cricket matches. So you say this part is common, so let me create a class first, and then I'll inherit this class into another class, so all these four properties come here directly, and then I just add the scorecard here, right? So what is the advantage of this over this? The major advantage of this over this is, let us say I'm also supposed to create entities for T20 and ODIs and tests. In this approach I'll have to replicate all these fields in all these classes. But here I basically say, okay, this is a cricket match and it can be inherited by one, two, three, four, as many classes as I want, right? So and in each class I'll probably just need to add the scorecards. That's it, right? So this is the overall idea, that whenever you are going to use inheritance, you basically try to figure out that the entity that I need, is there something which is common with other entities that I either need today or I might need in near future, for example. Okay, and if there are any things which are common between two or more entities, it probably makes sense to first create a class which is at a higher level in the hierarchy, and then start inheriting this class and adding more features to it. Okay, so this is a very simple inheritance example. This Any questions still here, by the way? Let me check the chats also. Okay, okay, no queries. Let me go back. So this was in the case where my class only had some fields, right? I did not talk about any methods. But actually, when it comes to inheriting methods, things are slightly more interesting in inheritance. Okay. So let us take two examples here. Okay, let us say I need a function, a method called flip the coin. So flip the coin essentially is a way in which you flip the coin to have a toss in a cricket match. So flip the coin is a method. What it does is it actually changes the state of my object. Okay, so in the beginning, when the object is created for a T10 cricket match, the toss field is set to, let us say, null. Null means nothing. And then this flip the coin method is called. Then at the end of it, whomsoever the team which has won the toss will be assigned to the toss field of the class. Just to give you an idea of how methods work. And another example could be add the scores, the scoreboards that I talked about. So with in the beginning of the match there are no scoreboards, so the scores array points to null, and then after the first innings is over, you add one scorecard to this field, and then after the second inning ends, you add the second scorecard. So again, going back to the same comparison, so in this type of in this mode of creating classes, I can simply go and add two functions here like this, right? In this mode, again I can think about the methods, what methods will probably be useful for any siblings, for example, of T10 cricket match. And if it is going to be useful for the siblings as well, maybe it is a better idea to put it here and add this add scores thing here. Okay. Huh. So let me just. So now we'll come back to this within a minute. But now to answer the question that that someone asked, that how do we really decide what things should get inherited and what things should not get inherited, and not just inheritance, right? I mean, what behavior of a class should be visible to the outside world, what behavior should not be visible to the outside world. So these questions are always going to be difficult to answer, right? There is really no short way to decide upon it. It has to be on a case to case basis, right? So as this I have already told you, in general we usually hide the fields of the base class from the derived class and let the derived classes access the methods. Okay, it is I called it a thumb rule, but it is not, as I said, it is not really a rule. It is probably a good way to start for beginners. And if you are a beginner, please make sure that if you are going against this convention, you have a good reason to do that, right? And this part also we have discussed, that the idea is that you should hide anything that doesn't concern the outside world, that is basically associated with the internal working, or it's a core behavior of that entity, which should not be modified in any ways. So in that case you hide it, otherwise you make it public. Okay, so all these object-oriented programming languages, at least the ones that I know, they have a mechanism to decide what could be private and what could be public at the member level. Okay, so each member of the class, field or method, you can decide whether it will be private or public. So you can do that at a member to member level. Now, there's one more thing that I want to discuss before we end this lecture, and this is known as overriding. Now, I showed you that example, right, where I said, let me add some method to the base class, and then let the derived class inherit it instead of adding it directly to the derived class. Now, the object-oriented world, it has a very powerful feature called overriding. We'll go through what overriding is later, but just to give you an idea what overriding is, this involves redefining a method of the base class in a derived class. So the point here is redefining. Okay, so it was defined in the base class. Okay, but now you said that the definition of the base class is probably not good enough for me, so I would like to define it myself. An example could be things like, let us say the class automobile has a method fill fuel. Okay, and because, right, all automobiles run on fuel, so you need to fill the fuel. So there is a method called fill fuel, and within this method, you're just printing, go to the filling station and get the fuel filled. Let us say that is all that you are reading, that you are printing from the fill fuel method of the automobile class. Now you understand that when you actually see automobiles in the real world, um, if you, for example, if you go to a filling station, the first thing that you'll have to do is you have to figure out what is the type of your vehicle, whether it is petrol vehicle, whether it is a diesel vehicle, whether it is a CNG vehicle, and then you have to go to the correct booth, right? I mean, if you have a petrol car, you should not go to a diesel booth. You have to go to a petrol booth, and this is something that is missing from the fill fuel method of automobile class, and it has to be, right, because automobile are too generic. It contains all types of automobiles, petrol, CNG, diesel. So there is no way to actually talk about these things at automobile level. But at the level of, let us say, a petrol car or a diesel vehicle or something like this, you know that this is the fuel type. So instead of writing, go to the filling station and get the fuel filled, you can say go to the fuel filling station and go to the petrol booth and get the petrol filled. Okay, so basically it's the same method, fill fuel, but in the derived class you would like to provide a separate definition, a different definition, as compared to what it has already been defined in the base class. So this whole phenomenon is known as overriding, that there is already a method, there is already a definition for it, but you are simply overriding it. Okay, and uh, in some cases, right, the class that I inherited just now, the base class, could actually be practically of no significance, right? So let me go back to the automobile example. If I just tell you, you said how's everything, and I tell you I bought an automobile, right? You'll be like, what do you mean by an automobile? Did you buy a bike? Did you buy a car? Did you buy a hoverboard or whatever it is? You'll have to be more specific, right? So maybe automobile is too generic, and this will happen when you write code as well, because what are you doing? You're trying to find out commons, you're trying to abstract things in hierarchies. So it is quite possible that in your inheritance hierarchy you have now reached a level where, if you try to create an object of this class, it doesn't really make any sense in the real world, right? I mean, you have to always provide more information so that people can understand what this object looks like. So in such cases, what we do is that we create an abstract class. Okay, an abstract class is a class which is only there for the purpose of inheritance, but you cannot create an object of it. Okay, such a class is known as an abstract class. Similarly, there is a concept of an abstract function. Okay, so this is a function which I have added in a class, but there is just a declaration, there is no definition. Okay, why? Because I say there's no point of giving any definition here. The derived classes will provide their definitions anyhow. So I simply say, okay, let us leave this function as it is without giving any body, without giving any definition for it. I'll just give a declaration, and I'll let the derived classes provide a definition for it. So such functions are known as abstract functions. In C++ terminology, they are also known as pure virtual functions. We'll talk about virtual functions later, but this is a terminology. Abstract functions is the common terminology across the object-oriented world. And in C++, the terminology for such functions is pure virtual functions. Okay, so again, don't be worried. We'll talk about overriding again later in the course, but this is just to give you an idea that sometimes you'll need your inheritance hierarchy will become so abstract. Okay, it will become so far off from the real world that you might consider a particular class to be a abstract class rather than a the opposite of an abstract class is a concrete class. A concrete class can be instantiated. You can create an object of a concrete class. An abstract class can only be used for inheritance. So this is another kind of forced example. But let us say I want to add one more method to this T10 cricket match called get maximum number of overs. So this is essentially a two-level hierarchy. Now I say let us add one more class here, limited overs cricket match, and I said this class is actually abstract. Why? Because as I said, right, when you say India and Sri Lanka played a limited overs cricket match, it doesn't really make any sense. You'll have to tell me whether it was T20 or ODI, right? So similarly, so this class is kind of an abstract class. You cannot create an object out of it, but you have a method here. This is an abstract method, a pure virtual function. And then when you inherit it to the T10 cricket match class, this function is no longer abstract. You will have to provide a definition for it. Okay, so the core idea is, in many a time in many cases during your inheritance hierarchy, you may have to encounter abstract classes as well as abstract functions, abstract methods. There is some homework, you can have a look at it. Any questions? It's boring, I know. I agree, it's boring. It's just that you need to know these concepts so that you can then try to implement them. And this is why I wanted to have projects, because um, projects are probably the best places to apply this knowledge, rather than asking you to write some code in a practical 1 hour or 2 hour exam. uh, projects will be much better, because you'll start from a problem. You will analyze your domain, you'll figure out what are the common attributes among different entities. You'll figure out some entities should actually be abstract, so on and so forth. Okay. Any questions, guys?
So overriding can only be used with means abstract methods or fields, or
No,
it
no,
can
it
be
can
used
be
with
it can
any.
be used with any methods. For abstract methods, it is a compulsion. If you are extending a class which has an abstract method, it becomes a compulsion for the derived class to provide the definition. But otherwise, for all other methods too, you can override them. There are of course some ways in which you can stop the overriding as well. But for now, just assume that you can override all the functions from the base class. And this is why I said, right, overriding a function basically means you are modifying the behavior of this entity, the core entity. And this is why I said that maybe not everything should be available to the derived classes, because the derived classes will then have an option, for example, to change the pizza base into noodles or something like this. Yeah, it's a poor example, but okay. Any more queries?
So if we override any method, so it
Mhm.
that method will be changed for all or only for that particular where we had override it.
It will be applicable for all the objects of this derived class. The base class will be as it is. Okay, if you create an object of the base class, the previous, the definition of the base class is applicable for that method. But for all the objects of the derived class, then this new definition will be applicable. Any more questions?
So suppose if one
Hmm.
method is there which is in base class and it
Hmm.
has three subclasses,
Hmm.
and for each one we want different uh, means result. So
Yeah, yeah.
we had override it in means we had override. So will it change for all the three or only for one?
No, no, no. So basically, what happens is, let us say you have a base class called A, and then you have three derived classes, D1, D2, and D3. And if you want to override, let us say, a particular function M, a method M, then the you can override it in all the three, D1, D2, and D3. When you create an object of type D1, the definition provided during the overriding in D1 will be applicable. Similarly, if you create an object of D2, so you understand, right, that different classes which are having the same base class can all override a particular method, and this overridden method will be applicable to their objects. It has nothing to do with objects of the base class, or let us say its siblings, as in other derived classes who are getting derived from the same base class. They are not affected by the overriding in one class.
So their children will be affected.
Yeah, of course. I mean, their children will be affected, because they will now see for them the base version has changed. Okay, so let us say if you have changed it in D1, and then you inherit two more classes, E1 and E2 from D1, then E1 and E2 will get access to the D1's version. You got it?
Yes.
Yeah. Okay. Any more queries? Okay. So this is I think this is you first of all, you don't have to call super. Okay. It is a common practice to call super. It is not a compulsion. Okay. It is only a compulsion with constructors. For all other methods, it is not a compulsion. It's up to you whether you want to call the super method or not. First of all, some context to this question. Super basically is a way to access the version of the base class. Let us say you now have two versions of this particular method. If you want to go back and access the base class version, you can do that with the help of super keyword. But anyhow, so coming back to yes question, it is not a necessity to invoke the super class function, but in many cases you will see that there is a kind of progression. Okay, progression as in, um, let us just go back to the example of automobile, right? And in the automobile, instead of fill the fuel, just assume that there is a method called repair. Okay, so in the repair method in the automobile, I have written find out where the engine is, number one. Number two, start inspecting the engine. These are the two things that are written in the repair method of automobile. Now, in the petrol automobile class, I override the same repair method, and let us say I want to write something that is specific to petrol engines, for example. But the things that are defined in the automobile classes repair function, find out where the engine is and start inspecting the engine. That is still applicable to the petrol engines as well, right? You will have to use these two things first, and then you start inspecting stuff that is specific to the petrol engine. So in many cases, in many real world cases, you see that calling the super version, the base class version, and then doing something afterwards is a very natural thing. Okay, so in those cases you see that whenever we are overriding the function, maybe the first statement that we do is we first call the base classes function, and then we do something more over it. Okay, so this is not a compulsion. It is it in many cases, in many use cases, it is a common thing to do. Is that clear? Yeah, so basically this is the kind of extending the behavior, you understand, right? The behavior of the base class, you are using that behavior as well, but over that behavior you are doing something more. So you first call that behavior, you let that thing run, and then you add something more to it. So you say, find where the engine is, start inspecting the engine. Then step 3 is in petrol engine you have to go and check this and and do that and stuff like that. So now this is step 3 in the progression. So you basically call the base class method in order to run step 1 and step 2, something like this. So any more questions? So okay, I'll start. I'm trying my best to upload those 2 lectures. I still don't know what will be the timeline. I'm having so many issues at the personal front, but I'll upload them as quickly as possible. I am available over email, so whenever you have a doubt and you don't really have to wait for a class, drop me an email. My response might take some time now. Okay, it is possible that I may not be able to reply back to you immediately, but I will reply back to you. Okay, so please keep on sending me emails if you have any doubts, and we will have an extra class of just for doubt clearing on 19th evening. Okay guys, I think the midterms start from Monday, right? So all the best to all of you for all the exams, and we'll meet again on 19th, and of course I'm available on email. Okay, thank you guys, bye.